Okay, so we talked about number one. I just started recording the video. We talked about number one. Okay, that's a linear, it's a line, so it should be mx plus b. We talked about the y-intercept was 4. And then we talked about the slope from here to here was down 3 over 1. So negative 3 should be our m for that one. All right, then you just got to put it mx plus b. Okay, number 2. So I want to do this again now that I'm recording it. Number 2, I just want to remind you, okay, the first point was 0, 1. All right, the second point was 1, 2. And then the third point was 2, 4. All right, so then for your table for this one, again, 0, 1, 1, 2, 2, 4. All right, and then just figure out, we got to figure out what we're multiplying by. And that should allow you to figure out which one of these is right. So remember how we did this, okay? We have to figure out, we have to find an x to start with. We have to figure out like somewhere that we're going to start with. And then remember, it's just the first y okay, and then it's times the pattern. And then remember, it's always x minus the first x power. And that's the exponent. All right, so I think what they do here is they definitely start with this as their first x and first y. They use the 0 for the first x, and they use the 1 for the first y. So that should help you figure it out now. Remember, 1 times anything is just itself. No, you're good. You weren't the only one. All right, now this one, okay? This just says, is this graph representing continuous or discrete data? Okay, we don't know what it's talking about. We don't know what it means, but we should be able to tell by looking at it if it's continuous or discrete. Okay, we talked about that. If you can trace the whole thing, it's continuous. If not, it's discrete. Right here, number 4. If you can trace the whole thing, it's continuous. If not, it's discrete. And then number 5 and 6, okay? On these ones, you're just trying to pick which graph best goes with the story. Okay, so think about that. Think about the continuous and discrete stuff. It's all kind of included in that. Same thing here. Temperature of the oven. All right. And then when we get to 7, okay, have you guys done this stuff before? Because I wasn't planning on going over it. But have you solved equations like this before for x? Okay, so all right, so like for whatever number this is, for 7. For 7, okay, whenever you solve an equation, we have to get the x's on one side. Okay, we have to get everything else on the other side. All right, so I'll do an example of a different equation, okay? I'll make it like 2x plus 8 equals 4x minus 2. Okay, so we need to get the x's on one side. All right, so don't write this down, but if you think about this, okay, we could either do this, right, and we could get them away from there, or we could do this and get them away from there. All right, personally, I feel like in like with my experience, you guys like to do the same thing I do with this. I like to keep the x's positive. So personally, I would have done it the first way. I would have taken away 2x from both sides. So that way, when I rewrite it, my x's are now positive 2. And this whole little homework thing, this will be I'm going to put this as on the YouTube channel, okay? I'll just call it like 3.1 practice quiz. All right, so we got to move the smaller x over first to keep them positive. Now we got to get rid of the minus 2 because we're trying to get x by itself. So we have to get rid of the minus 2 now, okay? Do that to both sides. All right. Now we'd end up with 10 equals 2x. All right, and then remember to solve this, we got to undo 2 times x. So we divide by 2, and x would have been 5 for my example. Okay. Any questions on this? Like, you're just undoing everything, trying to get x by itself. All right, so for 8, okay, when you guys get to 8, now we didn't really talk about what it was called, but that last equation we solved was a linear equation. Okay, so number 8, now this is an exponential equation. Remember, just because there's an x in the exponent. Okay, so exponents, remember, are like multiplication, right? Like 10 times 10 times 10, right? Whatever the exponent is. So what we're trying to figure out is how many times do we have to multiply 10 by itself to get 100,000? Okay, however many times you have to do it, that's what x is. That's the answer. You can think of it as how many times or how many tens, I guess, you'd have to multiply to get 100,000. Okay, so I'm just going to show you guys, like, this is literally how I solve those problems, and this is what I expect you guys to do. I expect you to go on your calculator and do 10 times 10, right? So that's 2 tens, and just keep doing it. That's 3 tens times 10 again. That would be 4 tens. All right, times 10 again. That would be 5 tens. Okay, and just keep going basically until you get what you wanted to get, which was 100,000. Well, I'm like sharing a bunch. I got a bunch of stuff going on right now. Okay, how do I get back to the meeting? Dude, I'm freaking out right now. Oh, I'm in it. I just need to open up this. Yeah, okay, my bad. Oh, go back to the example from question 7. Yes, so let me